Okay, here's the last video. So we were just talking about diffuse reflection. Diffuse reflection is when light bounces off of a surface, but it gets scattered. When it bounces off of snow, for instance, all that light is going to be scattered. It's going to hit your eye different, so you're not seeing a perfect reflection of the clouds off of the snow. You're not seeing the sun reflected off the snow. You're just seeing light. Refraction is a little bit different. Refraction is when the light wave goes through a material and it slows down or it speeds up. And the index of refraction tells us how much it's going to slow down or speed up as it goes from one material to another. So in a vacuum, it's fastest. When it goes through air, it's going to actually slow down a little bit. So when the N value, the index of refraction, goes up, it means that light is slowing down more. So let's take a look at a few examples here. So we have a block of glass, and I am shining a laser in. It's going from air to glass, and it's going to go through the glass, but it's going to slow down. And when it slows down, it's going to change its direction. So notice that it bends here. And then when it comes out the other end, it's going to go back to the speed it was. So it's going to have the same path. If you look at this path, it's the same as this path. It goes back to the speed that it does through air. Whenever you've maybe seen a fish in a pond, you're not actually seeing where the fish is. You're seeing where you think it is, because when you look at the fish, you're looking, but when it goes, the fish is between, there's water between you and the fish. So the light that you see is actually bending from when it's coming from the water into your eyes. So if he were to throw this spear, he would miss the fish because he would throw it where he thinks he sees it right here, when the fish is actually right here. Diffraction is a little bit different. We're just going to talk about this briefly, but when a wave comes through and it goes through an opening, it's going to bend around that opening. If it's a large opening, it's not going to bend all that much. But as we get over here and we get this opening that is a little bit smaller, it's going to bend more and more, and it's going to spread out even more through small openings. And lastly, we're going to talk about the electromagnetic spectrum. So this is light makes up part of the electromagnetic spectrum. A very small part right here, but it does get included. It's part of the magnetic spectrum that we can see. Below light, at lower frequencies, it's going to be infrared radiation. This is going to be heat that we experience. Microwaves, your microwave runs off of microwaves. That's going to be even lower frequency or longer wavelengths. Radio waves are the slowest. They're going to be the highest wavelength. They're going to be really long, but they're going to be the lowest frequency. As we get into the ultraviolet, which is actually above our visible light, ultra meaning above, and violet is at the end of our visible spectrum here, so above violet. This is UV sun's rays from the sun, which is dangerous. So anything greater than light in large quantities is going to be dangerous. Anything under light is going to be more safe. So infrared, fire burns hot. That can be dangerous, but the warmth is nice. We need to be warm in order to survive. So infrared actually is falls under the safe. Same thing with microwaves. You don't want to put anything in the microwave because it's really focused microwaves, but there are microwaves going around us all the time, and it doesn't really bother us all too much. X-rays, again, higher frequency here after ultraviolet. This is how we use it for medical imaging. And gamma rays, we don't really use all that much. They're the highest frequency. They're the most dangerous, and we don't really want to mess with it. This just outlines everything I just talked about, so make sure you take a look at that. So you're going to be completing the 2 assignments. The first assignment is Waves worksheet. Make sure you go fill out that Google form, go through the PowerPoint, make sure you understand it. Let me know if you have questions. And the assignment 2 is you're going to be drawing the electromagnetic spectrum, much like we saw on this, and you're going to be identifying where the electromagnetic spectrum waves are in real life. So microwave, TV, stuff like that. All right, have a good one.